When calculating the necessary ampacity for a feeder and determining the appropriate size of an overcurrent protection device, or OCPD, the National Electrical Code, or NEC, provides specific guidelines to ensure safety and proper operation of electrical systems. If your calculations result in a value like 920 amps for a feeder, selecting the correct OCPD becomes crucial. The NEC mandates that you must use a standard size OCPD. However, not every possible amperage rating is a standard size. In a situation where the calculated amperage falls between two standard sizes, the NEC provides rules for how to proceed. According to Article 240.6 of the NEC, if the calculated current does not correspond to a standard OCPD size, you must round down to the next lower standard size. It is essential to consult the latest edition of the NEC to ascertain the current list of standard OCPD sizes. As of the current edition, there is no standard 900 amp OCPD size. Therefore, after calculating a feeder at 920 amps, you cannot use a 900 amp OCPD because it is not a standard size recognized by the NEC. Instead, you must round down to the next lower standard size. In this case, that would be an 800 amp OCPD. Using an 800 amp OCPD ensures that the overcurrent protection is appropriately sized according to the NEC. It is crucial to avoid selecting an OCPD with a higher amperage rating than necessary. Doing so can create a significant safety hazard. An oversized OCPD might fail to trip in response to an overcurrent condition, potentially leading to equipment damage, fire, or other dangerous situations. The practice of rounding down to the next lower standard size for OCPDs is rooted in safety considerations. It ensures that the circuit is adequately protected against overloads and short circuits. By choosing a smaller OCPD, you enhance the sensitivity of the protection system, allowing it to respond more quickly and effectively to potentially harmful current surges. Always refer to the most recent edition of the NEC when performing electrical calculations and selecting OCPDs. Electrical codes and standards are updated regularly to incorporate new technologies, address emerging safety concerns, and refine existing practices. Using an outdated reference can lead to errors in design and installation, with potentially serious consequences. The NEC provides comprehensive tables and guidelines for determining the appropriate size of conductors and OCPDs for various applications. These tables take into account factors such as conductor material, insulation type, ambient temperature, and the number of current carrying conductors in a raceway or cable. Understanding how to use these tables is essential for ensuring that electrical systems are installed safely and in compliance with code requirements. Remember that the primary purpose of an OCPD is to protect the conductors in a circuit from overheating and potential damage due to overloads or short circuits. Selecting the correct OCPD size is critical for achieving this protection. When in doubt, consult with a qualified electrical engineer or inspector to ensure that your electrical installations meet all applicable code requirements. Rounding down to the next lower standard OCPD size is a specific application of a broader principle in electrical engineering, which is to prioritize safety and err on the side of caution. Electrical systems are complex and can pose significant hazards if not designed, installed, and maintained properly. By adhering to the NEC and following established best practices, you can minimize the risk of electrical accidents and ensure the reliable operation of electrical equipment. Always double-check your calculations and consult with experienced professionals to ensure that your electrical installations are safe and compliant with all applicable codes and standards. In summary, when calculating a feeder at 920 amps, the correct OCPD to use according to the NEC is 800 amps because 900 amps is not a standard size. Always consult the latest NEC edition for the most accurate information.